Alright, you've made it to the end of the book, Chapter 11, Network Address Translation for IPv4. Alright, we're going to talk about what NAT really is, how to configure NAT, and then how to troubleshoot NAT. So, IP4, when it was first designed, PCs weren't widespread. They thought, hey, with Class A, Class B, Class C, that's more than enough PCs or IP addresses, for the world. And then as the popularity of PCs grew, they were like, oh crap, this isn't going to work, we're going to run out. So private addresses were introduced to try to save the public IP addresses. Because again, when IP4 first came out and we had internet, every PC got a public IP address to use out there on the internet. But not every PC needed an address. General Electric bought 3.0.0.0. And they actually IP'd all their PCs so that their PCs could all go out to the internet. So again, they quickly realized, hey, this isn't going to work. We're going to run out of addresses. So we need to make a way so that everybody inside the company can just share addresses. They can be a private IP address, and then they can share like the one public IP address they get from the ISP. So the request for committee 1918 came up and said, hey, we're going to have private IP addresses. And the ranges are, 10, 172.16, and then 192.168. So they picked one IP address in each class and said, hey, these are going to be private. They cannot be routed on the internet. So most home networks are 192.168 something. And then if you're going to have more than 250 clients in your organization, you're going to use a 172.16. And if you're going to have thousands of clients at your business, you're going to use a 10. So again, most big hospital systems use 10, smaller medium-sized businesses use 172.16, and then our home and very small businesses use 192.168. So again, most of the home stuff is all set for 192.168. All right, what NAT does is NAT translates the public IP into a private IP and the private IP into a public IP. So in other words, let's say at your house you've got 4 different PCs. So you've got like an iPad, you've got a PC, you've got a laptop, and you've got a Roku box. So they need 4 IP addresses. Well, your router here would provide those 4 private IP addresses. You might get 192.168.1.100, 192.168.1.101, 192.168.1.102, that kind of thing. So it gives you out those IP addresses. And then it receives a public IP address from your ISP. And then every time one of those clients communicates, so like your laptop, when he hits the router, your router strips off the private address and then puts on the public IP address. And then everything that goes out from those 4 clients actually shares the same IP address outside. So the rest of the world sees you as your public IP address. So we typically see NAT on our border router here. So inside here we're using 10, 192s, that we're using the private IP addresses, and then when that traffic hits the router strips that address off and then puts the public IP address on, and then that's what everybody out there on the internet sees you as, your public IP address. And then because of that, we can have all these private IP addresses and we're not wasting public IP addresses. Every house in the United States can use 192.168.1.100 because it's all private and it's local to the house. And then it hits the routers, and then the routers are obviously assigning the public IP address. So remember, NAT is Network Address Translation. It translates your private IP addresses into public IP addresses because private IP addresses cannot be used on the internet. All right, with NAT, there's a couple terms you got to remember. Inside global, inside local. Basically, inside your network, these are local addresses. They're local to your house or your company or business, that kind of thing. Then there's global addresses, what the rest of the world see you as. So they've got it broken down into, there's an inside local and an inside global, and then there's a outside local and an outside global. Now, this isn't the best chart. If you look here, this kind of shows you here. So my inside local IP address is always the private IP address of the client. And then your outside global is the IP address that the rest of the world sees you at. So these are really the two addresses you need to use, or you need to understand. The inside local and then the outside global. Again, this is what your IP address is, the inside local, and then the outside global, what the rest of the world sees you as. And then the outside local would be the target that you're going to. And then the inside global can also be the target that you're going to. Because remember, inside here, your PC, let's say he's going to the email server. It would say, when the packet hits the router here, it says it's coming from here and it's going to the email server. So that address is there. So those aren't really relevant. We don't have to worry about the inside global and the outside local. You need to focus on the inside local is the IP address of the host. It's the private IP address of the host. The outside global is the public IP address of the host. So it's what it gets translated to. So I hope that kind of clears that up for you. All right, so again, lots of complicated diagrams and stuff. Just make sure you understand that the inside local is the address of the client. All right, I may have said that wrong. All right, so if you look in this diagram, it tells you, the inside local is still your PC. So inside local address is the PC. But here, your public IP address that the rest of the world sees you at is 200.2.226. So here, that's the inside global. But if you go here, it looks like the inside global is the target that you're going to. Remember, two of these are typically always the same. And if you go here, the target IP address is the outside local and the outside global. You see it's 201, 201. That's where, again, even I get confused on it. With things like ACLs and NAT, we don't do them all the time. Typically once you get it set up, you kind of never touch it again, unless for some reason your ISP changes or something happens. So I guess this is the better chart. So make sure you remember inside local is your IP address, your private IP address of the PC. And then your inside global is your public IP address that the rest of the world sees you as. And then don't worry about the other two. Remember, when we're using NAT, we're only going to set up, we're going to do a translation between this address and then this. So your private gets translated into your public gets translated into your private. As far as our NAT configuration goes, we don't deal with these two addresses anywhere. All right, so now that you're totally confused, let's talk about the three different forms of NAT. All right, the first one is what they call SNAT, or static NAT. And static NAT is a one-to-one mapping. So typically what happens, let's say I'm a small organization and I host my web server internally. So I need an IP address that the rest of the clients can use to get to the internet. And then I need a second IP address, a second public IP address that people can use to get to my web server. And then what I do is the web server address, I statically NAT to one specific IP address internally. So the one IP address gets statically NATed to the web server. And then the other IP address does not get mapped. It uses port address translation that we'll talk about later. So all the PC users can get out. So for static NAT, it's a one-to-one mapping. We're going to map a specific public IP address to a specific private IP address. And it's typically used to allow, web resources, like a web server or something like that is hosted internally into a company. We still do this today because there are some places that host things inside. There are some places that have to make a resource available to the outside world or to an outside partner. So we do still statically NAT. All right, so in this example here, which is actually a really bad example, they've got three things. They've got, let's say, their web server, and then they have two PCs. And then they statically NAT each one. So 10.10 gets statically NATed to 2000.226. And then .11 gets NATed to 227. .12 gets NATed. So remember, it's a one-to-one mapping. One private IP address gets mapped to one specific public IP address. And nobody can share, nothing like that. It's one-to-one mappings. All right, and then we move over to dynamic NAT, or DNAT. Now, DNAT uses a pool of IP addresses. So let's say I bought 20 IP addresses. Well, then anybody in my company, when they try to go out to the internet, they grab an address from the pool and they use it as long as they're on the internet. And then once they're done and they close the browser, that address goes back in the pool. But I can only have 20 people out on the internet, so it's first come, first serve. So the first 20 people that grab those addresses out of the pool, that when the 21st person tries to go to the internet, it's going to say, hey, there's no addresses in the pool left, you can't go out to the internet, you got to wait. So as far as, like, I have never run into a situation personally where somebody is using dynamic NAT. So it's kind of like the redheaded stepchild. So again, in this case, their NAT pool, they make a pool of 2000 or 226, 227, 228, so they buy 5 IP addresses. And then again, the first client that connects, he gets the first address, and then the next client that connects gets the next address. And then when he disconnects, then that address goes back in the pool. So you can see, I mean, you don't really need to use this because we're going to use the third of the choice. Remember, your first choice is static NAT, second choice is dynamic NAT, which nobody uses anymore, and then we're going to talk about the third. And that third choice is port address translation, or PAT. It's sometimes called overload, and like in the command that you use, you'll do overload on the command. So, and what this does, it allows one to many. So every home is set for PAT. Most businesses are set for PAT. So basically, you buy one public IP address, and then it translates all your internal clients to share that IP address. So at home, the situation where you got 4 different clients and they're all 192.168, 1.100, 101, 102, 103, when they go out to the internet, they would all have the same IP address. So the rest of the world would all see them sharing that IP address. So it's overload because you're overloading that IP address with as many hosts as you can. All right. So what what PAT does, it modifies, when one of your PCs connects. Hey, this is my PC. He's 192.168.1.100, and he's going out to the web on port 80. It modifies the address and the port number, and then it keeps a log of what it changed it to, and then it sends information out. So let's say 5 of you all send stuff out to the internet. It keeps track of all the changes that it makes in kind of a table, and then when packets come back in, it can go back to refer to the table and see what it changed your stuff to, and then send it in. And again, that way, everybody can share one IP address. So you don't have a lot of IP addresses that are exposed because the rest of the world sees your entire company as that one IP address. And PAT is even able to translate protocols that don't use port numbers like ICMP. So basically with PAT, we have many IP addresses to be translated into one, or to share one specific IP address. All right, so again, with NAT, obviously it's great because we're saving public IP addresses, and that's what has allowed us to use IP4 for so long. So we can serve the IP addresses. It does give us some security because everybody sees us as the same IP address, so they have no idea what our internal addressing scheme is. Plus, we can keep a nice consistent network. If you went to Time Warner Cable and said, hey, I need to buy 300 IP addresses in the same range, they may not be able to give it to you. They may give you 100 here, 50 here, 25 here, that kind of thing. So with NAT, you can use 10 or 192 or 172 and have a nice consistent network inside your network. All right, disadvantages of NAT, obviously performance. Imagine anytime you go out to the web server, let's say you go to Google or somewhere else, your packet goes to your router and it gets translated. So that takes time. Then it goes to the destination and it gets translated to the IP address of the web server. And then when that packet gets returned, it gets translated again at the source, and then it comes all the way back to you, hits your router, and gets translated again. So just for you to go to a web server, your packet gets translated 4 times. Tunneling is more complicated. You can't trace things because IP addresses get chopped off and modified at each transit. So it's really got a lot of disadvantages. And with IP6, we kind of get rid of NAT. If everybody can have a public IP address, there's no need for NAT. And with IP6, everybody on the planet can have a global prefix, and there would still be, a whole ton left for everybody else. So IP6 kind of gets rid of NAT. All right, so how to configure NAT now? Here's where it gets weird. All right, static NAT is actually pretty easy. Basically, you have to point, hey, here's my public, and I'm going to map it to this private IP address. And then you have to go to the interface and say this is going to be the in, and then this is going to be the out. So it looks like this. So IP NAT turns on NAT, And then you're going to say, I want to map this inside address to this static address. And then here's my inside address, and then here's my outside address. So that's all you have to do to map the statement. So you turn on NAT, and then you say inside is going to go to this source of static IP address. So pub or private IP address, inside, going to go to this static IP address. Then you go to the interface you're going to use, and he's going to be the inside, and then you go to the exit interface, and he's going to be the outside, and that's it. So 3 commands. 1 command to do the mapping, and then you have to say, hey, who's going to be the inside and who's going to be the outside. Obviously, if you're here, this is going to be your inside, and then when you exit, that's going to be your outside. So static NAT, nice and easy. All right, when you're verifying static NAT, show IP NAT translations is your command. If nothing's going on, it'll just show you, hey, I'm statically mapped this public IP address to this private IP address. If a NAT translation is currently active, these other 2 fields will fill in, and they'll show you like this is where he's going. So this public IP address gets mapped to this private IP address, and they're sending data to this address here. All right, you can also do, clear IP NAT statistics, and then show IP NAT statistics, and then kind of get an idea of what's going on. And they'll show you, how many hits, which things are getting hit. Hey, there's a static rule, there's a dynamic rule, then there's a PAT. All right, and then we come to dynamic. Dynamic, it's kind of weird because there's 5 different commands you got to do. So first, you create the pool. Remember, dynamic uses a pool. So here, IP NAT turns on NAT, and then you're going to say, hey, I'm going to create a pool, and I'm going to name it, super pool. And then the starting IP address, and then the ending IP address, and then what the subnet mask is going to be. So that's how you create the pool. Then you create an access list to allow the internal to use the NAT. Then you map those 2 together. So we're going to, IP NAT, turn on NAT. And we're going to say inside, and then the inside is going to be accessed by the source access list, number 12, or whatever you named your access list, and it's going to use pool NAT pool. So we got to create the pool, then we got to create an access list to allow clients to use it. Then we have to map the access list to the pool, and then we go to the interface and make 1 inside and 1 outside. So 5 different commands for dynamic NAT. Make sure that you're writing these commands down so that when you come into class, you have these all mapped out for you on paper. You don't want to be looking at the slides. All right, so again, to verify, show IP NAT translations is the big one. You can also do show IP NAT translations verbose to see what's happening at the time. And then again, you can clear the statistics and then show the statistics, and you can kind of see, how many hits are going across. All right, and then for some reason your book shows you how to make an address pool with PAT. I don't see a whole lot of need for this. I mean, if you have an address pool, why are you just not using dynamic? Well, because dynamic is terrible and you don't ever use it. I don't know anybody that's using this address pool. So you don't write any notes on this one. So again, you create the pool, you create the access list, you map them together, and then you do the inside-outside, just like dynamic. The only difference here is you put the word overload, and overload means it can use 1 address more than 1 time. So that's really the big difference between dynamic and PAT with an address pool. With dynamic, each client can only use 1 IP address, so each IP address can only be used once at a time. With PAT, with an address pool, each IP address can be used multiple times. Again, and I've never seen anybody using this. So what you're going to see use this. We use PAT with a single IP address to go out to the world. So this is how every home, small business, medium business, they're typically sharing 1 IP address to go out to the internet. Remember, every time you talk to your ISP and you buy a public IP address, it costs money. So why would you buy 5 IP addresses when you can just buy 1 and you're good? Now, it's not a lot of money. I think it's like $25 a month or something like that. But still, if you bought 5, then that's $125 a month. As opposed to buying 1, it's $25 a month. So you can just use 1 and save the company $100 a month or $1,200 a year. All right. So with PAT, you create an access list. So access list 12, permit the internal network. And then you map it. So IP NAT, turn on NAT. And the inside is going to get mapped to a list. and that list is going to be 12 or whatever number you made it, and then interface, whatever interface, and then overload, and then inside and outside. So it should look like that. No, apparently they don't show you the actual commands. But that's it. So with PAT, it's only 4 commands. You got to create an access list to allow traffic from inside. And then you map, you say, hey, I'm going to use this, from the inside is going to use this access list, and they're going to overload on this address. And this is the port number of the address they're going to use. And then you assign it to the inside, and then you assign it to the outside. So again, here's kind of how it works, and here's how it looks, from the server's point of view, or the router's point of view. And then here's how traffic looks like when it's coming back. And then to verify, show IP NAT translations. All right, so really that's it. Remember, there are 3 types of NAT: static NAT, dynamic NAT, and PAT, or overload. Static NAT is a one-to-one mapping. Dynamic NAT, you use a pool, but each address in the pool can only be used once at a time. And then you have PAT, which takes one address and allows everybody to use that one IP address. All right. Another thing that you'll typically do is port forwarding. And especially home users, we're seeing this more and more. Somebody wants to host their internal Minecraft server or their Call of Duty server or something like that. And basically what you do is you're going to forward a port. So you're going to tell the router, hey, anytime traffic comes into the public IP address and it's for port 27005, I want you to forward that to this internal private IP address, which would typically be your server. And that way everybody's going to hit your public IP address, but when the traffic comes in for that address on port 27005, it forwards that internally to a specific address. And that way you can host resources internally. So again, you can use that for web servers, things like that. So here in this case, when anything hits 209.165.222.225 on port 80, the router forwards it to the web server because the port is forwarded to the web server. Now, every router is different, especially your home versions. Like mine, I use the Ares from Time Warner Cable, and it's actually under virtual servers is where you actually port forward. So you have to look at it, but somewhere there should be something where it allows you to put, hey, this is going to be, the rule is going to be for a web server. I'm going to take port 80 and I'm going to map it to 1.254. So remember, my server is 1.254. And then anything that hits the outside on port 80 coming in that's not for established connections would go to the web server. All right, if for some reason you ever have to configure this on a Cisco router, basically IP NAT inside is going to get mapped to a static IP address, and it's going to be TCP protocol, private IP address 192.168.10.blah, port 80, and then the public IP address 8080, and then inside and then outside. So this way, anybody out on the internet can access, when they type in your IP address colon port 8080, and remember, when we say an IP address colon and a port number, we call it a socket. So whenever this socket is used and hits your router would translate it to 192.168.10.254 on port 80, and then forward it to your web server. So I don't know where you would theoretically use this in a business, because typically I would do static NAT here and just have a static IP address that maps to the web server. But if for some reason you only have one IP address, you could do this instead. But typically you can just call your ISP by another IP address and then map that to the web server and then have a static mapping. All right, so remember, with IP6, there's absolutely no need for NAT. It was a workaround in IP4 to save addresses. With IP6, you have 340 undecillion addresses, and I know I just said that terribly bad. So there's absolutely no need for NAT. But just in case, they did make some local addresses. They call them, unique local addresses. FC00 to FDFF are reserved for unique local addresses. So God help us if we ever use those. But what you will see is you'll see NAT64. And what that does is it translates IP4 to IP6 or IP6 to IP4. And this way you can have IP6 on your router on the outside, so you can be IP6 to the public. And then when your traffic comes in, your router would then translate it to IP version 4. Now, this is why IP4 won't really go away. a lot of companies, their IT guys aren't jack of all trades. Like they don't specialize in TCP/IP or IP math. And they look at IP6 and it scares the crap out of them because sometimes they see it and it's a huge number. Other times they see it's a small number. So, without education, these guys have no idea how easy IP6 is and how much easier it is than IP4. So they were like, oh crap, I'm just going to call a consultant. And the consultant comes in and says, oh yeah, I can do, NAT64 for you. And that way you can still use your IP6 on the internet. And then it'll translate to IP4 so you don't have to change anything inside. And they're like, oh, that's awesome, let's do that. So the consultant does that, then they don't have to change their internal network. So IP4 is here to stay. You probably won't see it go away for at least 10 years. All the IP4 addresses have been purchased, so they're all owned by ISPs, but the ISPs still have IP4 addresses to give out. Once the ISPs totally run out of IP version 4 addresses, and they start where they have to assign you an IP6, that's where you're going to start seeing people have to implement NAT64 on their devices. So make sure you're aware. All right, so troubleshooting NAT. Clear the statistics, clear the translation. You typically want to start fresh, and then look at the statistics and the translations and see what's going on. Is my stuff getting hit? Is my mapping correct? What port numbers are showing? Things like that. And then the old standby, debug IPNAT. Remember, debug commands turn on messages. So every time a NAT translation happens, it would pop up on the screen. Anytime anything happens with NAT, pops up on the screen. And that way you can see these translations. Hey, a packet came in, public IP address to private IP address, or public IP address to blah. So it shows you everything on the screen. And that way you can kind of see what's going on. What is it trying to translate? What's the public IP address being used? What's the private IP address used? Did I put it on the wrong interface? Things like that. And then remember to turn it off, undebug all. All right, so just a quick recap. Static NAT, you need three things. You need a rule to map an inside to a static. So we turn on NAT, IPNAT, and then we map an inside source to a static IP address. And then the inside address to the static IP address. And then we go to the inside interface and we turn it on, IPNAT inside, and then we go to the exit interface and we turn it to the outside, so IPNAT outside. So 3 easy commands. All right, dynamic NAT, you got to create the pool, then you got to create an access list, then you got to map the pool to the access list, and then you make the inside and the outside. All right, and then for PAT, you make the access list, you map NAT to the access list to the interface. So here, IPNAT, inside is going to use this IP or this access list, and it's going to use the address of this interface, so interface FA00, and it's going to use overload. And that's the command that tells it, hey, whatever address is on this outside interface, that's what I'm going to use, and I'm going to let everybody use that address. And then obviously you have to do inside and outside. Now, remember here, you can do these NAT commands in any order. So like in this case, they make the pool, they map the pool to an access list, then they do the inside outside, then they create the access list. So you can do them in any order, but you need to have an order that works for you. Like for dynamic NAT, to me it makes sense to create the pool, then create the access list, and then to map the two together, and then do the inside outside. It just makes more sense. All right, so again, like I said, you can do these in any order. So here we do the inside and the outside, and then we create the access list, and then we map the stuff together. So again, you can do it like this, but for me, it just makes sense to do the things in order because then it kind of makes sense as you're describing it. Hey, I got to create an access list to allow traffic from the outside. And then, hey, now I got to map that access list to an interface and turn on overload. And then I got to assign it to the inside-outside. That makes sense to me. But going here and saying, oh, I got to turn on NAT on the inside-outside, but I haven't even created NAT yet. So that doesn't make sense. But again, whatever works for you. If this willy-nilly, woo, just doing stuff crazy works for you, stay on it. If you're a person like me that likes to keep things in order, nice and logical sequence, do it like that. All right, and that kind of wraps it up. So this week we'll be doing a NAT lab. And then next week we'll be finishing up with your hands-on exam. And again, we'll talk about in class. So again, if anything in here doesn't make sense to you, or you want to see examples, let me know when you guys come in the class for lab day, and I'll work the stuff on the board where it kind of makes more sense. Kind of hard to do that here. All right, so we'll see you in class.